Okay. So here on this question, you can there are two ways we can solve it. So we can try to introduce the logs. We can try to introduce the logs. So we can introduce the log. Now, we are going to introduce log to base what? Who can decide which base here? What base can we suitably use so that things can work to our advantage? What base can we use? I just want you to try. What base can we use? Okay, so we're going to introduce the log to base 2. So I'm going to say log to base 2 of this, which is 2 to the power 2x plus 3, plus log base 2 of 2 x plus 3, which is equal to log base 2 of 1 plus log base 2 of 2 to the power x. Now this one here, since we have 2, 2, 2, 2 throughout, and we have a 2 here, because the whole idea of bringing log base 2 is so that we have these 2 and these 2 are equal, these 2 and these 2 are equal, these 2 and these 2 are equal. So this one also we can write it to base 2, of which is going to give us 2 to the power 0, if you wish. So we have 2 to the power 0, which is as good as a 1. So now, by the power, using the power rule, we can drop these powers here. So I'm going to have 2x plus 3, okay, log 2, 2, plus we can drop this one, x plus 3 log 2, 2. This is equal to, we can drop the 0 here, 0 log 2, 2, plus we can drop the x here, x log 2, 2, like that. So now because of this, this is 1, this is 1, this is 1, this is 1, because the power here is 1, power is 1, power is 1, power is 1. So this simply gives us a 1. Remember, when these two are the same, you pick the power here, and the power is just 1. So 1 times this, we get 2x plus 3 plus, this gives us a 1. So we have x plus 3 is equal to 0. There's no need of writing the 0, because this times that we get a 0. So you get x there, because this also gives us a 1. So you get just an x there. Okay, so this x and that x are going to cancel, because the moment this x crosses the equal sign, it's going to become minus. So it will be x minus x. So it will cancel. So this x, that x will cancel each other. So I'm going to remain with 2x. 3 plus 3 is 6. So plus 6 is equal to 0. So this gives us 2x is equal to, when it goes the other side, it becomes negative 6. So over 2 over 2. This, that cancels. So x is equal to 2 into negative 6, we get negative 3. So x is equal to negative 3. Yeah. So that's what we have there. Any question? Any question? No question. Okay. No questions. So let's move to something else. Yeah, something else. Something else. So this one we are done. Let's move to something else. Okay. So the next question is the next question is 2021. So we have 2021, April, May, 2021. That's This is still AEE. So we have question 1D. Question 1D. It says solve the equation for real values of x. So we are solving this equation, which is log x plus log is equal to 2. So we want to find the value of x. So now here we have this. Now you already have an idea for this. What do you have there? What do you have here? Anyone to quickly tell us the answer here? What will this give us? Yes, Brandon.
Will it give us 1?
No, don't ask me, Brandon. Just tell
1.
us what you exactly. So you suggest it say to give us a 1, and the 1 is correct because you said when these two are the same, you pick the power there, and the power is 1. So I'm going to have log x plus 1 is equal to 2. Okay. So from there we're going to say log x is equal to 2. This one will cross the equal sign, it goes the other side, it will subtract. So we're going to have log x is equal to 2 minus 1, we get 1. Now, remember now we need to rearrange this. We need to rearrange this. It should be x is equal to something. So x is equal to what there? Yes, who can pick it up? Recently, x is equal to what? Remember where we are coming from? We are moving now from a log to something like that. X to the power something. X is equal to something to the power something. What do we get? Listen, yeah, they only read their parent. Sorry, yes.
Is it 2 to the power 1?
2 to the power 1. Okay, 2 to the power 1. Okay, Derek, where's Derek? Is that correct? Derek. Sorry? Okay, Jibala, is that correct?
Yes.
Joshua, is that correct?
Let me keep following.
Okay, Brandon, is that correct?
I think so, sir.
Okay, so this is correct. Yeah, this is excellent. That's excellent, listen. Because if you are going to rewrite this, it's going to be log. Okay, so this number that has a power, remember, we said 10 squared is equal to 100. So we said rewriting this would be log. This number which has a power, okay, the one that has a power is the one we put down here. So even here, the one that has a power, we are going to put it down here. Then this which is on the other side is what we are going to put here. So here, this which is on the other side is what we are going to put here. Then we put an equal sign, we put an equal sign. Then the one which is the power is what we are going to put there. So here, the one which is the power to x here, or this power rather here, is the one we put here. So we have gone back to the log if we write it that way. So reversing, we simply get that. So I hope that is making sense. Sometimes you can over explain things and you start confusing people. So I hope this is making sense to everyone. So this is what we get. So we simply get a 2. We simply get a 2. Just a 2. Yeah. Any question on what we have done? Before we can move to the next question. Yes, Jibala.
Okay, there you said you get the 2. Then the 2 was raised to power 1. What if that 2 was raised to a number like 3 or any number apart from 1?
So this question will tell us if this 2 was raised to power 3, then our answer is x is equal to 2 to the power 3, you get 8. So our value of x will become 8. Hope that is helpful.
Okay, okay.
Great. Unless there's any other question, we are moving. Okay, so we move to AME. This time around I have an AME paper question. AME question. AME question. Okay, so AME, so we have, this is November, December 2023. AME question 1A, which says simplify and write as a single logarithm. As a simple logarithm. Simplify and write as a single logarithm. As a simple logarithm. So simplify and write as a simple logarithm. So we have x to the power square root of log x, which is equal to 10 to the power 8. Okay, so we have that problem. It's from AME 2023, November, December. Okay, so we have to write this as a single logarithm. So log something is equal to something. That's how we should write the answer. Okay, so now here, what we can do, the best we can do is to introduce the log both sides. So the log we are going to introduce, we introduce the log to base 10, so that we can easily have log 10, 10, and then we can cancel things out 10. So I'm going to say solution. So I'm going to say log base 10 of this, which is x to the power log x, is equal to log base 10, 10 to the power 8. Okay, so next stage we can drop the powers. So we are dropping this power, we are using power rule. So I'm going to say log root of log x. Okay, it's multiplying by log 10 like this. This is equal to, we can drop the 8, so I'm going to have 8 log 10, 10. Now, this one I'm sure already you're understanding that this will give us a 1. Okay, so we'll get just 8 there. So I'm going to have root of log x log x like that is equal to 8. Any question? Whom have I left behind so far? So that you don't remain completely very far. I hope we are moving together. We have only applied we have introduced the log both sides, we have applied the power rule, and we have dropped down the power there, and also the power there. So we have this, and this one gives us a 1. Okay, so now at this stage you introduce the square, you square both sides, square here, square there. So what do we get when we square this side? Quickly, who can tell us the answer there? When we square that side, what do we get? Or maybe let's say when you have root x, you have, let's say, x root x, then you square this. What are you going to have? X root x. What are we going to have when you square that? Yes, Joshua?
I think then you remove the root number.
Come again?
The root number would be removed.
What about this one? Without a root.
Just refresh.
Come again?
All I know is when you square a root number, the root is removed.
But this one Kai is outside the root. That's correct. What about this one which is outside the root? What happens to it?
Multiplies with the remaining number. I think.
Okay, Brandon.
The number that's outside there gets a power of 2.
Uh-huh.
Then the one with the square root is cancelled. It gets cancelled, so you get like x squared x or something like that.
Okay, great. Let's say, thank you. I appreciate those answers. So let's say we have 4 times 4. And then we say, let's take the root like that. No, let me use 2 as a quite smaller number. So 2 times 2. Okay. So, what is 2 times 2? Yes, Brandon?
4.
4 squared. What are you going to get?
16.
Good. So here 2 times 2, inside here are going to get 4. Then 4 squared is going to give us 16. Now, what if we take this square root inside? We say 2 squared is to be 2 squared times 2 squared to be 2 squared. What are we going to have? 2 squared is 4 times 2 squared is 4, and 4 times 4 we still get the 16 without any problem. So we can take this square root and apply it to individual numbers and maintain the multiplication in between them. So this is what happens here. So when we bring this one, we can simply say, okay, we're going to have x squared times, here we have root of x squared like this. So this one will remain as x squared times the root of x, this and that cancels, we just have x. So x times x, same base, we add the powers, so it will be x to the power 3. Who is behind? Okay, so we move, let's come back to this now. So here, with what we have discussed, what are we going to have here? Yes, Brandon.
We'll get log x times log 10 x to the power 2.
Now, I forgot to mention, so log, when you just see a log like this, log something, it means it's base 10. So the 10 usually is not included. It's just removed. Then you know you're dealing with base 10. So here you can even decide to remove this 10, but I have included it so that you know how this, what will happen here. So we can, even if we just have log, so even this one under the root, it's actually log to base 10. So it's as good as when we say the square root of x. We don't put a 2 there. So the moment you see just a square root like that, without any number here, you know you are dealing with the square root, meaning there's a 2 there which is hidden. So that's also with the log. The moment you just see a log, it means it's log base 10. Okay. So what Brandon is saying here is this one, the square, this square will cancel with that root, so we're going to have log x. Okay. Then this one, this is not a base, it's actually what we are looking at, log x. But the base is 10, like I was explaining. So this log here, since it doesn't have a root, it will be squared. So it will be times, then this will be log squared x is equal to, what is 8 squared? Jibala, what is 8 squared?
4.
Good. So we get 64 here. get 64 there. Okay, so
Let's go.
give it. That's what I give you.
Let's go get it.
Bring. Okay, go now, money. Go and give money. Okay, go and give money. Good boy. Okay, so we continue. So log x. This one is squared, this one is not squared. So what are we going to do here? What will happen here? Who can suggest what will happen there? Yes, Chibala.
Okay, so there, since we have log x times log x power 2, so we'll get log x, and then we'll add the power, so it will be, wait, I forgot.
Okay, Brandon. I saw your hand.
Yes. So I was thinking, since we have log x times log squared x, we can simplify, and
How?
maybe we can get log x times 2 log x.
So this 2 drop here.
Yes, that's what I was
Now
thinking. It
this
drops there.
2 is not on the x. Mind you, it's only the power of x that can drop here. This 2 is simply telling you are saying this square, you are saying log x times log x. So there are 2 logs that are multiplying each other twice. That's why there's a square here. If it was a square of x, it was the power was on x like this here. That's why we are able to drop it. But if the power is on log, we can't drop it. So there's a difference there. The power rule only applies to the power of x, not the power of the log. Don't be tempted to do that in the exam. So the way we did the x there, this is log x, this is log x also, except this one is squared. So we add the powers. This is log to the power 1. This is log to the power 2. So we add with the same base, we add the powers. So this is going to give us log 3x, like that. Okay, because this is log x, this is log squared x. So when we multiply, we are simply adding on the powers of the logs. So it becomes log x, log 3, log x, log cubed x. This is equal to 64. So now we can use the cube root on both sides. So we can do the cube root of this so that we can get rid of the 3, cube root of that. So what's the cube root of this? The cube root of this is this and that is going to cancel. So I mean with log x is equal to, what's the cube root of 64? Cube root of 64? Quickly. That one should be in your head. Yes, Chibala.
It is 4.
Okay, good. Brandon, I hope that's your answer.
Yes, sir.
Okay, so at this point we have expressed as a single log. And we are done. Any question? Okay, now next time you are going to find it a question which says solve, meaning you are finding the value of x. So when you are asked to solve, it means you are finding the value of x. So let's find the value of x here. But our question ends here, since it was saying are expressed as a simple logarithm. So this is a simple logarithm. It's simpler than this. This one is not even expressed as a logarithm. Okay, so let's find the value of x here. X is equal to what? From this here. X is equal to what? Remember, this is log base 10. Yes, Chibala?
I think x equals to 10 power 4.
10 to the power 4. Okay, who has a different answer from that one? Anyone with a different answer from that one? Okay, so that means everyone agrees to that one. And it's correct. So now here, what would be the value of x? Simply be 10,000. So the value of x is 10,000. When you put log 10,000, the square root there, and you put 10,000 here, it will be exactly the same as 10 to the power 8. Exactly, without a difference. Okay, so we are done with that question. Any question?
Yes, sir. How do we leave the answer then?
Come again?
I was asking, so how do we then leave the answer? Because you said that as far as log base 10x equals 4, that is what they asked for. Do we have to then further solve for x?
No. The question says expressed as a single logarithm, so you end here. This one is an addition question. Like, what if next time you're asked to solve for x? If you're asked to solve for x, meaning you extend from here to that. Just 2 steps, you are done. Is that fine?
Fine, thanks, sir.
Great. Any other question? Okay, so let's look at another question from avionics paper. So this is avionics 2023. We had this very interesting question as well from avionics. So if you come across questions, solve them, and then you can let me check your answers. Yeah. Okay. So this was avionics 2023, July, August. Question 3A. So the question says, let 2 log x plus 2 log y is equal to 5. So show that log x is either 2 or 1/2. So we have that question there. So we need to show that log x to base y is either 2 or half. So now we have log x base y, but here you have log y base x. And we're asked to find this, which is now this one here. So meaning we need to change the base for this one, so the base for this one can become y instead of what we have there. So that we can have the same base throughout. So you're saying solution, this is going to be 2 log x. Now remember how we change the bases. Remember, I hope you still remember how to change the base. So we have 2 We are changing the base of this one to y. So the base should be y because we need, the question says base y. Okay, so I'm going to say log base y over log base y. Okay, then what do we do from there? I want someone who understood what I said. I've done something already, so it should be easier from there. What do we do from there? Hey, hey, hey. Yes, you're too quiet. Can I start pointing? Derek, what do we get there? From there, what do we do?
So I'm not sure.
Manjay, Derek, you are not sure all the questions. Next time you should volunteer by yourself. Sorry for that. Yes, who wants to help Derek? I know it's been long since you touched these things. Who wants to help out? Liseli?
I knew you were going to point at me. I knew. So I'm just not sure, but I'm solving them in my mind. So I'm just trying to be clear. So it will be log. The top one, yeah, log. Log the base y.
No, I've already put the base y here. I want something here.
It's going to be y.
Y here. Then down.
X.
X. Okay, so this is correct. So when you are changing the base, you write a new base up and down. Then now this that you have here, these two, the one which is up there, you put it up. The one which is down here, you put it down. Then you are done. It should be that simple. Then now I'm saying this is equal to 5. Remember this gives us a 1 on top here. Then now, because this is in the denominator, we can multiply throughout by this so that we can remove it from the denominator. Okay, so we can multiply throughout by log x, like that. So when we multiply this times this, it's like we are having the same twice. So this is going to give us 2 log squared, the base here is y, and we have x, like that, because this and this are exactly the same. So that's why we have a square there on the log. Then this times this is in the denominator, this is in the numerator. So this and that, they are going to cancel. And remember, on top there is a 1. So 1 times 2, here we are simply going to get a plus 2. This is equal to 5 times this, we are going to get 5 log x, like that. Who is behind? Whom have I lost? Yes, Joshua. Come again.
You're moving a bit fast.
Okay, but you have understood what we have done.
Following.
Okay, good. That's
I'm
most
copying
important.
what you're writing at the same time.
Come again.
I said that I'm copying.
Oh,
what
great.
you're writing at the same time.
Ah, great, great, great. But don't miss the understanding.
Whilst writing and still writing and
Ah, great, great, great. That's important. So understanding is most important. Make sure you don't miss the understanding part. Yeah, because it's better you understand. Even if you don't copy, once you understand, then you're good to go. So we have this. We can rearrange this to have 2 log squared x, we can bring this one the other side, minus 5 log x plus 2 is equal to 0. So we have actually formed a quadratic equation. We have formed a quadratic equation. So now this quadratic equation, I hope you have not forgotten. Now I hope I have not rubbed where you haven't copied. I hope you have copied up to that point.
Do not rub the last line.
Ah, great, great. So I've left it. So we have 2 log squared x base y minus 5 log x base y plus 2 is equal to 0. So now from here we are saying, what we are saying now here, we can let this become something else. We can say what are we going to let that become? The log, whatever, we can let it become what variable? Chibala, pick a variable. Okay, yes, Brandon.
So we can let log squared, we can let it be
A.
probably then, yes.
And then you're saying something?
No, just that.
Okay, great. So it's not the log squared, it's the log x base y. So I'm going to say let log x is equal to a. Okay, so that's what we have. So now meaning here it will be a squared. Here it will be a. That's what that means. So therefore we have 2a squared, because this log now it's a, minus 5a plus 2 is equal to 0, which is a quadratic equation with the variable a. So now here let's use product sum factor. Product sum factor. What is the product, Derek? What is the product? Okay, maybe Derek is sleeping. Joshua, what is the product? Jibala, what is the product?
It's to multiply 2a squared times 2.
So what do we get?
4a squared.
Joshua, is that correct?
Yes, it's correct.
This said, is that correct? That we get 4a squared?
I don't know. Isn't it 5 and 1?
The product, they said.
No, I don't know, sir.
You know that a grade 12 can just walk over this question without any problem, because they do this at grade 12. We are avoiding to use the quadratic equation formula. Yeah, because that's long. When you're alone, you can use that one, because we are behind. We are running up against time here, so already we are remaining with about 20 minutes or so. So we need to be done with whatever we have in the remaining time. So that's why we can't use long methods like the formula. Brandon, what is the product there?
Is the product -5?
So the general quadratic equation is ax squared plus bx plus c is equal to 0. That is the general quadratic equation. So product is simply a times c. So a times c gives you the product. The sum is simply b. Sum is b. Then factors. These are the two numbers that when you multiply them, they'll give you the product. When you add them, they'll give you the sum. That's how we find the product sum factor. So now let's get back here. What is our product? Chibala, I want to see if you have understood. What is our product now?
is 4a squared.
No, you haven't understood the what I've just said. Yes, Brandon?
So our product will be 4.
Good. Because here I'm simply saying you get the A, which is the coefficient. So here our coefficient is 2. Then you get the C, which is that C. You have nothing to do with the A squared. The A squared only tells you to say this is now your A, because your A always is the coefficient of this variable, which is squared. So whatever is the coefficient, the number in front of the variable which is squared, that's your A. Whatever is in front of the number the variable which is not squared, that's your B. Whatever doesn't have the variable of consideration, that's your C. So when you're finding the product, simply multiply A times C, which is this times that. Forget about the variable of consideration. So 2 times 2, you get 4. So the product is 4. Then what will be the sum? Literally, what would be the sum?
-5.
Okay, correct. So you get -5. So what are the two numbers such that when we multiply them, we are going to get 4. When we add them, we are going to get -5. I need those two numbers. Quickly, what are those two numbers? Yes, Brandon?
-1 and -4.
-1, -4. So you get -1, -4. Okay. So when we multiply -1 times -4, you get 4. When we add this, we are going to get -5.
How do we find this number?
Okay, so that's what we have there. So from there now we can say we have 2a squared, where there's -5 there. You want to explain? Go ahead, come and explain. I don't teach that. This is grade 12 week. I don't teach how you get those.
But you're teaching how to find them.
Okay, how do you find them? I don't
Get
know.
the factors of the product.
The factors of the
Mostly
product.
it's the product, yeah.
No, the factors of the product is 2 and 4. I can't say any 2 there.
It's 1, 2, 4.
Ah.
So you look at the one which you can
Okay.
adapt to the sound.
Please go ahead, man.
But the one which can adapt to the sound.
Okay, so sorry for that. And my boy wants water, so yeah, he wants to join the class and drink. He has missed the father the whole day, so when he sees the father again, he's still teaching at home, he feels jealous. He wants to join the class. Okay, so yeah, my wife was just reminding me to say you can also explain how you get these two numbers. So now these two numbers, you look at the factors of the product. So plus or minus 1 is a factor of this, plus or minus 2 is a factor of this, then plus or minus 4 is a factor of that. So from here, you look for the perfect combinations that can multiply to give you that product, and that can add to give you the sum. Okay, so he reminded me to explain that part. I hope you appreciate that part there. Okay. All right, so now when we reach here where there's the sum here, we replace with the factors. So I'm going to say -1 times a, we get simply -a minus 4a. So -a minus 4a, you get -5a plus 2 is equal to 0. So here the a is common, so you can take the a outside. So we're going to get 2a minus 1. Then here the 2 is common, so you can say 2. 2 into this, you get -2a. Okay. Then yeah. So let's use -2 here. We factor out -2 so that we have -2 into this, we get 2a. -2 into that, you get -1. So this is equal to 0. So there's this 2a minus 1, 2a minus 1, which is common. So you can factor it out. 2a minus 1. So here we take away 2a minus 1, we remain with a. So here we take away 2 minus 1, we remain with -2. And this is equal to 0. So this only tells us that 2a minus 1 is equal to 0, or a minus 2 is equal to 0. So 2a, when we take 1 the other side, we're going to have 2a is equal to 1. So we can divide by 2 here, divide by 2 there. This and that cancels. So it gives us a is equal to 1 over 2. Then here, when we take the 2 the other side, we are going to have a is equal to 2. Okay, but remember, we're saying but a is equal to, remember here, a is equal to log x. So where there's a, we're going to replace that. So that gives us log x is equal to, we have a is equal to 1 over 2, 1 over 2, or the same log, we're saying log x is equal to 2. And this is what we are asked to show. So you can say hence shown. Okay, so we have shown that that log there is either a 2 or half. Any question? So this question required you to change the base. Earlier there when we are starting, any question? Yes, Brandon.
I wanted to know, sir, how many marks was this question worth on the
Ish. Let me try to check from the papers. This was Avionics 2023. April. Okay, let me try to see avionics. That's July, August. Question number 3A. Okay, so this question only had 5 marks. Did you get that, Brandon?
Yes, sir, I did. Thank you.
Yes, it depends on the one who is examining. Yeah, people differ in terms of how they award marks. So some put a lot of marks on a question that has nothing, literally nothing. But some, for you to just get those marks, you need to sweat. Yeah. Okay. So great. So I hope there are no other questions. I think we can do the last part, then we can call it a night. There is one more question here, which should be AEE July August. Yeah, we can do this one and call it a night. Then we consider other things for tomorrow. Okay. So this is 2022 July August. This is AEE question 1A. So this question said simplify. So we have natural log of x squared over y squared plus 5 natural log of y minus 6 natural log of cube root of xy. Okay, we have that. So now here we want to apply all what we have learned there earlier. No, when we are multiplying, when you are dividing, when you are shan. Yes, so let's begin. So I'm saying solution. So now here we are dividing. Now you treat the natural log just as you treat the logarithm. So it's exactly the same treatment you give it. So the way we treated the natural log, this is exactly the way we treat the log. This is exactly the way we treat the natural logarithm. So here we have natural log of x squared over y squared. So how is this going to be when we split it here? We are supposed to split it. So how is it going to be? Quickly, Brandon.
So we get natural log x squared divided by natural log y squared.
No. Try again. Yes, Joshua.
Follow, sir.
Come again.
Following.
Following is that full time. Listen.
Natural log x squared minus natural log y squared.
Correct. Minus natural log of y squared. Because these two are dividing. Remember where we are coming from. So when they are dividing, you subtract. Then plus 5 natural log of y minus 6 natural log. Now we can rewrite this in terms of a power xy. So what power are we going to have there? If we have a cube root, how can we rewrite the cube root in form of a power? Yes, Brandon.
We can rewrite it in form of to the power 3.
No. Yes, Liseli.
To the power 1 over 3.
Correct. So when we have root of x, this is the same as x to the power 1 over 2. Because there's a 2 there. So now since we have a 3 here, it will become 1 over 3. Okay. So that is good as the cube root. So it's when you say 1 over 3. Okay, so from there we are saying natural log of x squared minus natural log of y squared plus now let me suggest that we drop the powers. We use the power rule and drop these powers. So I'm going to have 2 natural log of x minus 2 natural log of y plus 5 natural log of y minus we can drop this power, so I have 1 over 3 times 6 natural log of xy, like that. So we know that this here 1, here 2. So we're going to have 2 natural log of x minus 2 natural log of y plus 5 natural log of y. Then here we have minus 2. Okay. Then here, when we split this out, what are we going to have? Yes, what are we going to have there? Derek, you are too quiet. Okay. Okay, but can everyone else see what is on the board?
Yes, sir.
Yeah, also on my monitoring screen here, I can see literally everything and very clear. So it could be the network. I know the network at Zast is not very good. Okay, Joshua, what are we going to have there? We need to split those two there. Joshua. Okay, Brandon, yes?
we'll have natural log x
Uh-huh.
plus natural log y.
Good, correct. So this is what we're going to have. So now we're going to have 2 natural log of x minus 2 natural log of. So we can even add here. What do we get? So that we don't keep on writing the same. What is minus 2 plus 5 or 5 minus 2? We get 3, isn't it? Which will be positive. So it's like 5 minus 2, we get 3 natural log of y minus. Now here we can multiply this minus 2 times this, we get minus 2 natural log of x. The same minus 2 times the other one, we still get minus 2 natural log of y. Okay, that's what we have there. So you can group the like terms. Now before you even group the like terms, you see that there's natural log of x here and natural log of x here. This is 2 natural log of x, this is minus 2 natural log of x. So automatically this and that cancels out. Then you have 3 natural log of y, here you have minus 2 natural log of y. So 3 minus 2, that gives us 1. So which is just natural log of y. That's what we have. So you cannot add when these are in the powers. You cannot add here. Say this minus whatever, even if this was x, you cannot work out these things. You have to drop the powers for you to either add or subtract. So you have to drop the powers the way we have done. So you drop the powers and then you can either add or subtract. If there's need of raising the powers again, this 3 will go to y and so on and so forth. So you can move around there and then everything will be all right. Okay, I think we have reached the end of our class today, unless if there's any question before we can wrap it up. Yes, Liseli.
Can we solve one question again?
We are behind time, Liseli. This is 21:55.
Okay.
So you have a question?
Yes, I solved it, but I couldn't find the answer. So I needed help.
But why didn't you give me the question during the day, Liseli?
I thought you were going to bring it up.
Is it among the papers that I've mentioned?
No.
Yeah, so the best is you give me the questions during the day when you know the topic we're dealing with, so that we can work them out together. So yeah, you can what can we do? You can try, then let me see the answers that you get. I'm sure after learning today you should be able to take the different approach. Brandon, I've seen your hand. So you should be able to take a different approach and maybe get a different answer and then try to submit it. I'm avoiding using WhatsApp. That's why yesterday I called for a meeting for submission of work. So we need to use a different mode of submitting our work, and it's easier for me to mark there because I'll mark, literally marking. You even see to say, okay, here's marked correct, here's marked wrong. And like on WhatsApp, I have to just write up here, there, shining, which may not be okay. And WhatsApp also gets full sometimes and the like. Yeah. So try out that question. You can share it in the group, that small group, the Veta, whatever, April intake and the likes. Share it there and then let others also have a look at the question and try to solve, and then you submit the questions to me. Yes, Brandon?
Yes, sir. I just have 2 questions just for getting in order the program. So any work we do throughout the day on our own, we can submit to the Google Classroom and you see it and get back to us from there.
Yes, on the topics that we have done.
And then the second question, so as agreed upon last week, the next topic we're going to start tomorrow is trigonometry.
I should think so.
Okay. All right, sir.
Unless if we have made any changes. So it stands that we are doing trigonometry tomorrow. Yes, Joshua.
So we'll stick to the schedule Monday to Wednesday.
Come again?
I'm asking, we'll stick to the schedule Monday to Wednesday, 8 to 22 p.m.
I think that's what we are doing. So I don't know why you have to make that request.
No, I'm saying I'm confirming with you to say that we'll stick to the same timetable.
Oh, okay, it's a question.
Yeah,
Ah, great. I thought you are proposing.